Good morning, everyone. Welcome to my talk about C# 7.0 and also a little bit of C# 7.1. This week I have actually 5 talks, so I hope to see you on the other ones as well. They will be in the auditorium. Later today we'll talk about C# internals. This is just an overview over here of the new features in C# 7 and 7.1. Later we'll go behind the scenes and see how those features actually are built and how they are implemented. Tomorrow we'll talk about .NET Core internals, .NET Performance, and building your custom Roslyn plugins, so how to build custom tooling inside Visual Studio. Okay, as usual, with the exception of one of my talks this week, the performance talks, I will have no slides whatsoever. I'll just go into Visual Studio and write some code. So without much further ado, let's just switch over to Visual Studio and start taking a look at what's new in C# 7, and then later, for the time that remains, we'll talk about C# 7.0, okay? So let's just create a new console application. I'll create a new console application here, and I'll target .NET 4.7, but everything I show here is also available down level on older versions of the .NET framework. You may just have to install some additional NuGet packages, for example, to get the tuple feature. This also works in .NET Core. I'm just going to use standard .NET framework console application here in .NET 4.7 in order to demonstrate everything I'm going to show here today. Okay, I'm not going to create a Git repository for this. You know, it's not going to be something I will want to keep later. Okay, so let's get started with the very simple features. First of all, we have a couple of features, and I have an anxious mouse cursor there. Okay, good. First of all, we have a couple of features that make your code more concise, more readable. In fact, C# 7 and 7.1 are kind of releases where we are exercising the new way of building the C# compilers, language support in Visual Studio, and so forth by using the new Roslyn codebase. So we can actually do a lot more small things really fast, and that also shows why we actually have releases like the point releases like 7.1, 7.2, where we don't have big, massive features, but we have a lot of things that are really convenient. Okay, so one of those very convenient features over here is, for example, binary literals. Let's just start with that one. So in in C#, we've always had, of course, just decimal literals, 1024, for example. We've also had hexadecimal, 0xFF, for example, but we never had binary. And so if you do something like flags enums, so you have an enum, foo, and you have different options like a bar and a crux and a baz, you have to give those, values that are powers of 2. And so in order to make that a little bit easier, you can actually now use binary literals. So you can say 0b1, 0b10, 0b100. And of course, you can insert some zeros over here to make this a little bit easier. On the I like this, some leading zeros, and I've actually already messed the whole thing up. It's going to be a good day, I can tell you. But you see, like, you can now have binary literals, and they start with 0b. If you like capitals more, you can also use 0b with capital, of course. That's not a difference. Now, of course, if you have a lot of these guys, so I'm going to just omit a couple of them, but say that at some point I also have a flag called Fred, and I also have, a very big bit mask over here, like, something like this. It becomes kind of unwieldy to read those kind of things, like there's a lot of zeros over here. Well, what we also introduce here together with this feature is digit separators. So you can actually put underscores to group your digits together like this, any way you like. So if you want to use them in groups of 4 or groups of 3 or groups of 17, you can do that. You can also put multiple underscores here if you like. So you can actually make your code more readable, which is also useful, of course, for very long numbers. Say that, for example, you have mat.py, and for some reason you want to redefine this. Let me just copy this thing. And you want to really be able to read, how this thing is structured. You may want to separate things, in groups of 3 over here to make your code a little bit more readable. So you can just insert underscores at will in any numerical literal, whether it's a binary, a hexadecimal, or a decimal literal. So those are some very, very small features. Now, second set of features that we have is expression everything. What we actually did in prior releases of C# was give you a concise notation to, for example, do properties. Let me give you an example. Say that you have a class circle and you have a public double radius, with a getter over here. You may actually want to have a surface calculation over here And you don't want to store this thing, so you don't want to like compute the value of the surface and store it in there. You want to have a property where traditionally you would have to write something like get with a return radius times radius, you know, whatever, right, you know, times math.py, like this. Yep. Font size, of course, you know, here we go. Better? Good, okay. Yep, there we go. All right, so we created this one before, and we can now actually go ahead and actually use the arrow syntax like this. You know, this was a C# 6 feature, nothing new under the sun here. But we've also introduced this arrow syntax in a bunch more places now. For example, if you have a constructor here, and the only thing I'm going to do here with my radius is assign the radius property with that value, I could use the arrow syntax over here as well. If I like, I can also use the arrow syntax in getters and setters. So in the past, this only worked for read-only or get-only properties. Say that you have a property here called int x like this, and you want to have a get which does something like get returns 42, and set does something like, well, whatever it wants to do over here. For example, throw not implemented exception, you can do that. So now you can actually have this arrow syntax behind a lot more things. And in fact, this is the power of Roslyn being open source. This was actually a contribution from a community member who said, like, well, you've introduced this beautiful arrow syntax. It only works for properties and methods, but it doesn't work for things like constructors. It doesn't work for finalizers. It doesn't work for get and set. So that guy actually did pull request to the GitHub repo, and we actually pulled it in. And here's the feature sitting straight inside C# 7.0. Now, one more thing that you see over here is actually that I'm using throw in the body of something that's supposed to be an expression. Throw never was an expression in the past. Throw has always been a statement, so it doesn't have a value. So one other thing that we've done is actually make throw a expression. And so you can actually use throw in an expression context. Let me give you an example. Say that you have an interface iBar, and all my samples here will, of course, be bars and foos and quixes, you know, because it's a language demo. You know, I'm not going to try to pretend to build some accounting system or whatever. But so as I implement this interface, you see this is the classic way of implementing the interface, nothing new here. But I can also do control dot and use expression-bodied members for methods. So you see that it actually recognizes that throw can be used in an expression context. Now you may wonder, like, why that's actually useful. Well, a good example is this. Say that you have class foo, and we'll have a lot of foos and bars and quixes, as I promised you. But so say that you have something like this, public, let's say, static void bar over here, and it takes in a string. One thing you typically do over here is something like, you know, if s equals null, throw new argument null exception. Hopefully you use C# 6, so you can use name off over here. And then you will do something else. Maybe I will pass this thing to crux. And that's a private static void crux method, which does the rest of my computation. So I will have some code here. So as you do that, you kind of undermine the ability of using the beautiful arrow syntax, because, well, throw was always a statement. The if statement also has to be on separate lines. But hey, what? We already had this double question mark operator. The double question mark operator introduced in C# 2.0 as part of nullability actually allows you to say use s, the value of s, unless that value is null, or like this thing is a null reference, then I want to use some other value instead. So in the past you could do something like s, you know, question null, or like, you know, a default value here. But because throw is now also an expression type, you can actually put this thing over here as well. So now you can actually say use s. Unless s is null, then I want you to throw an exception. So you can actually have all your argument checking for nulls, for example, sitting straight in here in line. And of course, as you do that, you will actually see that this thing now suggests to use an expression-bodied member, and you know, you can get like more and more concise that way. So we've actually lifted some old statement constructs into the expression land, which means that they actually work, for example, with the null coalescing double question mark operator. They also work with things like the conditional operator, all of these things, okay? So that's a couple of examples of some rather small features, okay? Now let's actually talk about some bigger features. One of the biggest features in C# 7 is actually the support for tuple types, okay? Now, the .NET framework has always had tuple types. Well, not always. Since the introduction of the dynamic language runtime in 4.0, we've actually had system.tuple, which allows you to bundle up a bunch of values. You can, for example, have a tuple with a string and an int, and you can then say s equals new tuple and put in, bar and 42, for example. Now that's all great, but this doesn't have any language support. There's no support in the language to actually new up those tuples. Secondly, those tuples are quite expensive. Those tuples are actually classes, so they're heap allocated. Now, if you actually think about places where you pass around data, we've actually been passing around data in the languages that we all know and love for decades now, for example, through parameter lists. So if I take a look at main over here, I have open paren and a close paren over here, and I'm passing in an argument. So I'm kind of passing things around all the time, and yet we don't have a first-class citizen in the language to create a construct that says, I have two values here, and I want to sort of pair them together and either pass them into something or return them from something. So that's what tuples actually give you, is the ability to put things together. So let me start with showing what the language syntax looks like. So instead of writing all of this, this messy stuff over here, you can just write the following. String, int, stuff equals bar, 42. Okay? And so the open close parentheses syntax is the syntax that you use to actually construct a tuple. And now this is actually a type. This string, int is a type, it's a tuple type, and in fact it's actually a synonym for value tuple of string, int. Now what's a value tuple? A value tuple is pretty much the same as a tuple, as the one you've seen before, but one key difference with a value tuple is that it's actually a struct. If you see over here, you can actually see that this thing is a struct. So value tuples are very cheap. They are stack allocated, they can just be passed around to parameter lists and get returned, and they're actually first-class types. They're just types that can be used anywhere else. So for example, if you want to create a dictionary that maps, for example, a string onto two string values, you can now do that without having to create an auxiliary class. You can just say a dictionary that has string as the input, and then, as the values, it has, for example, a string, int pair. Now, of course, one thing is not very ergonomic about those things. If you take a look at all of this, well, how do I access those components of that tuple? Well, it's item 1 and item 2. Well, that's not very nice. That's the same thing that we had with system.tuple. Do you really want to call those things item 1 and item 2? Item 1 is the bar, and item 2 is the 42. Of course, the answer is no to that. So what we can do now is actually we can put names in front of these things. Let's say that's the name and that's the age. So this is apparently a person, where the name is bar and the age is 42. It's a funny name. But now I can do stuff dot, and I can actually dot into, whoops. Let me use var here for a second. I'll explain what I'm doing here in just a moment. But you say I can do stuff.name and stuff.age. So what's happening here is that I can actually give component names to the items of a tuple. And the CSharp compiler will actually track that through the type system. So for example, if you return a tuple out of a method, you can actually have those annotations in there, and then the call side will actually see those things using those different names. Okay, so now what can you do with those tuples? Well, one good example is they can be used to return multiple values out of a method. That's one of the classic, things that is pretty tricky to do in a language like C# today, and yet it's very asymmetric. If you have a method where you want to return 2 things, well, what do you have to do today? Like, I can take in 5 things, that's not a problem, a date time, D, but I only have like 1 slot to return things. So people often start off with like using out variables at the end. So something comes out on the left, something comes out on the right, and this is not very, very easy to consume. I'll actually show you a C# language feature in just a moment that makes it a little bit easier to consume out parameters as well. But say in this particular case, I don't want to use out parameters, I really want to return multiple values. Well, you can simply say over here, I want to return an int A, an int B, and a string C, for example. And now I can write some code, and I can return 1, 2, bar, for example, out of the method. Just like I can pass in, a triplet of things, I can return a triplet of things, and there's no limits to how many things you can pass in or that you can return here. So now you have ways to actually return multiple values. Okay, so that's a very, very simple example. Now, once you call this thing, So I call x, for example, and say this is a method that returns you the min, the max, the average, the covariance, the standard deviation, the median of some statistical data structure. That would be a very useful way to actually be able to return those different values. So now on the call side, how do I consume this? Well, the simplest thing to do, of course, is you just call that method, say bar, 42 long, datetime.now. There we go. And of course, I can, assign this thing to something like int, string. If I really want to declare the whole thing, I can actually, declare that type over here just using parentheses. But alternatively, I can also just write var, of course, as you always can do it in C# 3.0. We can infer the type for you. But there's other things you can do. You can also take this thing apart immediately. As opposed to writing this and then saying, well, I want A out of this thing, which is tuple.item1, but I can give them names over here, like I can put A, B, and C over here again. I can actually write A and B and C here, but it becomes quite verbose to sort of get the results out of this thing in multiple steps, right? String C equals tuple.c. So you can also deconstruct this thing on the spot. The deconstruction syntax simply allows you to write it like this. Int A, int B, int C equals that thing. In fact, you can even infer the type of certain components if they're too tedious to write. You can actually put vars in there as well. And if you don't care about something, you can use an underscore, which is a discard symbol, which says, I don't care about that value. I don't want to give it a name. I'm not going to use it. So if I don't care about those two things, I can actually put underscores. So now it's completely symmetric. You can pass in a comma-separated list of arguments. You can also return a comma-separated list of pieces of data. You can pick what you like. You can actually deconstruct it on the fly, as I've shown over here. And now I can just use A and B and C. They're all in scope locally. Okay? So very symmetric. It's kind of restoring the symmetry of parameter lists versus return types. Okay? So that's what tuples allow you to do. Now, starting with C# 7.1, there's actually one more little feature in the tuple types. That feature allows you, when you create a tuple, to actually have the names chosen for you. So say that I have int x equals 1 and int y equals 2. If I create a tuple here, like say var t for a tuple which will contain two ints, and I pass in x and y, in C# 7.0, you will actually see, starting with 7.1, you will actually see that x and y are inferred names for the components of the tuple. Okay? In the past, you would just see item 1 and item 2 over here. So if we can actually infer a name from these things, just like we do for example, anonymous types, where you do something like new x, y, we'll also infer that the name of those two properties is x and y. In here, we do exactly the same. So you can write t.x and t.y over here. Okay? So that's how tuples look, simple ways to actually bundle multiple values together. And the beauty is that they're actually value types. So you don't give them, or they don't have an additional cost in terms of heap allocation and garbage collection. You can also stuff those things, as I've shown you before. You can actually stuff them into data structures as well. So you can totally have a list of, for example, over here, double average, double sum. So you can actually have a list of those guys, and then just new up that list over here. So you can have a list and just ad hoc construct a type that consists of multiple values, okay? So that allows you to create, for example, a multi-dictionary. Very common request. I want to have a dictionary where I have keys that are composite. Like I want to index into this dictionary using 2 keys at a time. How do you do that? Well, either you have nested dictionaries, a dictionary of int, dictionary of string, double, or you can now have a dictionary of open parentheses, int, string, double. So the key is an int and a string, and the return value is a double. So those are just types that play along with any other place where we expect to see types. Okay? So that's a very brief overview of tuple types. The gist of it is you can bundle values together very easily. Okay? Now, I was actually talking about the out syntax just a moment ago. And that's one of those typical places in C# today we have some friction. It's something that doesn't sit in the flow when you're actually writing code. I'll give you an example. How many times have you written something like this? String, object. Assume that you have a dictionary of string, object, and you want to get a value out of it. So you say, well, I want to do if, let me put it one line lower because I'll need a white line in just a second. I want to do try get value, and I want to get the value out at bar, and I want to stuff it in a variable. Oh, Lord, I don't have a local variable available yet. So you have to go up, you have to insert object O over here, and now I can use O over here, and everything's good. That kind of interrupts your flow. You just want to have a local variable on the spot, a local variable that's available in the nearest enclosing member in this case. So how do you do that? Well, you already see in C# 7, we give you this light bulb here to help you with this, and it will actually hint you at using a C# 7.0 feature. This is called inline variable declaration. So inline variable declaration just allows you to declare a variable in place. So if you do something like try get value or int or try parse, you no longer have to introduce a local yourself. You can just have this thing introduce a local for you. And obviously, we can also infer the type for you. If you like to use var over here, it's some hideous long type, you can actually put var instead as well. Now, typically, you may do something else. I've intentionally chosen here to make this a dictionary of string to object so that it's weakly typed. Maybe you can do it better, maybe you can have better strong typing in this case, but in a lot of cases you don't have the luxury of having a strong type here. So I have an object now. What you typically will do next is something like n, O is int. Then I want to do something, and then the next thing you will do is int x equals cast to int of O. And then you will do console write line, bar is plus x. Well, of course, you will not write that anymore, I know that. You will actually just use string interpolation from C# 6. You will write this instead. But still, you have done a lot of stuff. You've repeated the same type twice. You had to say is int, and then you had to do a cast to an int. You had to do a type check and then a cast. If you have a string over here or a reference type, you typically do something even more contrived. Let me show you the other thing that you may want to do. Say that O is a string. You want to do something if O is a string. Now, I already have an O, so I'll call this O2 in this case. And O2 is string, and then I will cast O2 over here to a string and call this string S. That's one way you could write this. People have done that. Some people then turn on code analysis, and code analysis will say, for performance reasons, I see that you actually have done a cast here and a type check. You've done an is and a cast. I recommend you to use the as keyword. Well, where do you use the as keyword over here? So some people will say, let me introduce the string s over here and do something like s equals O2 as string, not equals null, and then use s. Like, people have done all that kind of stuff to just do a type check and all that kind of voodoo. So what we can do now is we can actually use patterns. We can actually do something better than just is. The beauty of is that we already have to do the check, and typically the common language runtime gives us the result of that type check. It gives us, the variable converted to that particular type. So what we can do as well is we can just write no is int x. I can now put a variable declaration in that same syntax. So I can say, if this is an int, name it x, and then I can use x, okay? Same thing over here. Get rid of all of this thing. O2 as string s, like this, okay? Beautiful. Not as, is. Okay, so now I can use as over there. This all works totally fine with also definite assignment rules, which means that in this case, try get value is guaranteed to assign to O2. So I can actually use O2 over here, and I will be able to use s to the right of this. So I can do something ns.length is larger than 0, for example. So all of these things are just being brought in scope. You don't have to have those variables yourself. Now, one thing that's interesting about is that we can now give it variables. But we can also go one step further than that. There's actually a big brother to is. The big brother to is the switch statement. So we've also taken the liberty to actually extend the switch statement to be more powerful. So what I have over here is something, I'm checking in a dictionary, I'm getting an object, and if it's an int, then I will do something here. If it's a string, I will do something else. I can actually make this much more compact by actually using the switch statement. So what I'm going to do is I'm going to get rid of those checks over here. Let me just put them, somewhere. I'll just park them, right? So I want to write all of the code over here, and I want to check whether O is an int or O is a string with some additional condition, mind you. And in either of those things, I want to do something special. Like, for example, this could be a base class and you want to check for the more derived types of that base class. Like it's a shape and I want to check whether it's an ellipse, and I want to check whether it's a circle. I want to check whether it's something like a rectangle or maybe a square, okay? So in this case, I'm just going to check for int and string. How do I do that? Well, you can now write switch O, and you can say case int x, console write line of x, case, string s over here, console write line of s. And I should not forget my breaks, otherwise it will say control flow cannot fall to the next label. So here you go. You can now just, take something and you can do switches not just based on values, which have to be compile time constants. You can now use switch against a whole bunch more things. You can actually use switch against, for example, types over here. We plan to extend this also with much more pattern matching capabilities. And the other thing that's interesting is that you can also write additional clauses. We call those guard clauses. So you can write something like case string s when s.length is larger than 0. That's all very similar, by the way, to the stuff you've seen in the catch statement, try catch exception. Try catch is exactly the same thing. When you do try catch, you have to declare the first type you want to check for, the second type, the third type, the fourth type, and so forth. And in C# 6, we also introduced the when keyword, so you can actually do a filtered exception with an additional Boolean condition. So here, this thing will only enter this branch of my switch in case O is a string. Never mind, that string will also become available as a local variable called s. So you see that I have static typing here, s.length. And it will also only enter this class in case the length of the string is larger than 0. So, well, of course, it's a very, very concise way of actually writing those things. Now you can also write more cases here. You can have case no, something like this. So you can actually have much more cases in here. You can also have cases with constants, of course, like we've always had. Like you can have case with strings and ints and all that stuff. You can even have cases with any kind of expression. So you can actually have a case against the value, and it will actually be an equality check that will be performed on your behalf, okay? So that's everything to do with making, first of all, out variables much easier to declare. You don't have to introduce the variable yourself in the outer scope in order to be able to do this. Secondly, you can use the is keyword, right? Like, if x is int, if O is x, like this. But if you have a lot of them, you can also go to the switch statement, which is like a multi-way branch, a multi-way if statement, okay? So that makes it very concise to be able to do these kind of things, okay? Good. So let's see what else we actually have up our sleeves. One more thing that we actually have is something called async return types, or generalized async return types. So let me talk briefly about that one as well. With C# 5, we introduced async and await, which makes it super easy to actually write asynchronous code, right? I hope everyone has been using async and await. It's kind of getting, in pretty much every single API, we have async capabilities now. So you can actually use async and await. In C# 6, there was a little bit of additional work done to make that feature more powerful. In particular, async and await was actually working, or be made to work also in the context of catches and finalies. So there's a bunch more places where you can actually have an await. And that was just because, in C# 5, the team hadn't figured out completely how to be able to interrupt exception handling in an asynchronous manner. So that's also been restored. Now, there's actually two more things. First of all, in C#, ever since the introduction of this feature, if I have an async method over here, I can await something, right? And if you await something, let me say var t equals task.delay. The compiler uses a pattern underneath. It uses a pattern using methods like getAwaiter, with isCompleted, onCompleted, getResult. Like it emits codes against all those members. It builds a whole state machine, a whole bunch of stuff, voodoo that you don't have to do yourself. So this is extensible. When you take a look over here, when I go over T, over task, I will just read it for the people in the back. It says at the very front, awaitable. It just sees that this is a type that's awaitable. In fact, I can create my own types that are awaitable. Let me just try, really quickly over here. Just, as a little challenge, class myTask, right? Like if I have a myTask over here, the compiler will not say that this thing is awaitable. Definitely not. Okay. But if I put on it a public method, which is called getAwaiter, and let me actually make that method return myself, just not to have to declare too many types. And if I have a public boolean is completed with a getter, and if I have a public void uncompleted over here, action, action, and I can just say throw not implemented exception, because that's what we already know that we can do now with the arrow syntax as well. And if I have a public int get result over here, which can always return 42, it's a nonsense thing. And if I implement I notify completion, which is a requirement imposed by the compiler, here we go. Oh, I don't want a constructor. Now if I hover over myTask, it says awaitable. Okay, so it's an extensible language feature. That's exactly the same for example, for each. The for each keyword works against anything that implements get enumerator, move next, and get current. Okay, the current property. So this was extensible all along. Now there's one thing that's not extensible up to C#7. In C#7 this restriction has been lifted. That's the return type of an async method. So in this case, task was pretty much the only thing that we can use here. We can also use task of int, and we can use void. Those are the 3 types that are allowed. So this was kind of, a fixed set of types that are allowed in the return position of an async method. So what has been done is that we actually have extended the support for that, and we can actually have any type be a task-like type, provided it implements a bunch of machinery. Now, we don't expect a lot of people to implement that machinery. I'm just going to show you that we have a new type in the .NET framework that actually supports being returned out of an async method, and that's called ValueTask. Okay? So let me just add a reference over here to the library that contains that. It's actually called system, I have to spell that correctly, systemthreading.tasks.extensions. And you will actually start seeing libraries that take a dependency on this DLL. Eventually that will get merged into the .NET framework, and it's available in .NET Core, no sweat. But now I can also return out of this thing something called a value task. And you see the compiler doesn't complain. If I was doing that in C#5, it would say like, no, this thing is reserved. This spot is reserved for void, task, and task of t. Now you can also have something like value task over here. Now what's the difference between task and value task? Value task is actually a struct. And so you will start seeing a lot more APIs that are high performance APIs to return value task instead of task. Now you don't have to worry about that because this thing is awaitable. You can just await it and you will have never known that this thing was a value task, but you can also return it out of methods. So why would you return a value task over a task? Well, value tasks are structs. They don't cost you much, but they really contain 2 things inside. They contain either a result or a task that eventually will produce a result. So the place where this is used is in situations where you have something that has to be async for the worst possible scenario on Earth where this thing has to go async. But at the same time, it's very probable that this thing already has the value available at the point it gets constructed, because maybe the value is already synchronously available. So value task is something that's super cheap. It doesn't have any heap allocations whatsoever in case the value is already ready at the point you want to await it. But it can also support holding on to a task of t result, which contains an eventual value to be computed in case the value was not available at the point you construct this. So when you do something like task.result, when you do task.result, you always have a heap allocation. You always have to create a task which has to be garbage collected at some point. With value task, you can actually create that thing either as a wrapper around a regular task or containing a value inside of it that's already available. And so a good example of that is if you build some API that's asynchronous, and maybe you have this kind of situation. I have a method over here, let's say filter of t, which takes in a func of t to bool, and that's my predicate, right? And so you're going to filter a whole bunch of things by actually going through this predicate function. This is like the where in link. But then the next thing you want to do is, I want to make this thing async, okay? And now you have the same code twice. You have, the whole code for the synchronous world in here, and you will likely do a copy paste in here, and we'll make this thing task of bool over here. And then somewhere deeper inside, you will evaluate the predicate on some element, right? But you will await the result of the predicate. And then here you are just doing the predicate. So you're kind of copying all of that code. You know, you're copying all of the code just to have an async API available because somebody says, well, I want to pass in a predicate function, but I want to back this thing by going to the file system, or I want to make a web request or something like that. Mind you, that's 1% of the users who wants to do something asynchronous there. The other 99% are just going to do something like, you know, x goes to x larger than 0. Okay? Now, as you see that code being duplicated, you may say, I want to consolidate this. And so what people are going to do to consolidate this is they will actually try to implement everything in the async method over here, which will await predicates, and then they will say, well, I can actually implement this guy by using the other guy, saying item goes to task.fromResult of predicate of item. Beautiful, okay? And so what's happening now is that I've chained everything to this code. My code duplication goes away, but I have done task.fromResult here. And in a lot of cases, you know, well, in all the cases in this case, the value is available immediately. So that await will be expensive. You know, it has to go through the task, get awaiter and all of that kind of stuff, which is not too terrible. But you know, this guy is the performance crime. This guy is allocating task objects containing values all over the place all the time. So instead, what you could do is you could use ValueTask over here. ValueTask of bool containing the result of evaluating the predicate, and then I will use ValueTask over here actually. There we go. See? So that actually allows you to improve some performance in some performance critical APIs. And there's something wrong with my battery charging over here. Okay, one last feature I want to talk about, actually two more. In C# 7.1, we've also introduced the ability for main to be async. Okay, so you can now have an async main as opposed to having to write your own main method that does some asynchronous stuff and blocks on it. We will actually implement that stuff for you. So you can now have async main, so with async task, and you can also have async task of int like this. Okay, so those are the two possibilities that you have here if you want to have a return type. Now, I want to actually show you how you enable this. By default, this will not work if you try this at home tonight, including in Visual Studio 2017 and what have you, because we've introduced over here in the build menu, we've introduced this thing called the language version selection. And I've actually changed this thing to, I haven't changed it, it's still in the default value. Yep. I'm gonna boost this font actually. Here you go. So you see the language version over here is actually set to the latest major version, so that's 7.0. And this is a 7.1 feature, so you actually have to change this thing to 7.1 here, or you have to say, I want to use the latest minor version. So 7.0 is the default. We will actually have 7.1, 7.2, and so forth. You have to opt into those things. So you will actually put over here that I want to use the latest minor version like this, and then that feature will actually work, features that are available in C# 7.1. So that's that new gradation in picking your language version. Because it's the first time we introduced minor version numbers, we've sort of introduced an additional dial over there. So now you can actually have async task. And there's another feature that's introduced in C# 7.1, which is actually called default literals. So say that you have list of int x's, and you want to put the default value over here. In the past, you had to do default of list of int over here. Well, you see it actually gets grayed out over here, and you can just write default on the right-hand side. You don't have to repeat the same type. Of course, you have two choices here. You can either say default on the right, which can be used to pass in a default value to, for example, a parameter in a method where you want to pass in the default. In case it's for like initializing a variable, you can also totally use the var keyword on the left here. In this case, those two things have a similar way. The one thing is called local variable type inference. That's var. We infer the type from the right-hand side. The other thing is called target typing, where we actually see what the type is on the left, and we can actually infer the type that the thing on the right has to have. That actually already existed for null. Like the null keyword doesn't state a type, but it's an expression. So it needs to get its type from somewhere in that context. So you have exactly the same thing for default here. You can be as verbose in repeating the type, but you can also just state default here. And you can use it anywhere where an expression is expected. So when you call a method, for example, you can also use the default keyword to give a default value to some parameter without having to specify that whole parameter or anything like that. Okay. So those are that's kind of a whirlwind tour over the C# language features. You can actually follow all the stuff that's going on in the C# language design on a couple of places online. So first of all, we have this place called github.com/.net/C#lang. C#lang is actually where the discussion happens of the language design. So there you can actually find proposals, for example, and also notes from design review meetings. So you see over here C# 7.1, which already shipped, 7.2, which is in the process of being shipped, and then over here on the C# 8.0 will eventually be all the notes of things that have been suggested for C# 8. There's a couple of things to point out here. First of all, we're working on async streams. People who were here in the previous talk by Mark Fussell from the Windows Fabric team, or Service Fabric team better, he actually showed asynchronous enumeration over collections. So that's something that may be coming in C# 8. There's no guarantee, but it's very high on the list of things that the team is looking into. So that includes asynchronous disposal, async disposable, as well as asynchronous enumerable and asynchronous enumerator. So that's C# 8 potentially, with suggested consumption syntax using a for each keyword with an await in there. So that would be something like, for each await var x in axis, where axis is an asynchronous sequence of values that may be streaming in from some data source. So that's asynchronous enumerables. And a second big feature that's coming is nullable reference types, where we're going to try to do the same things that the folks over in TypeScript have done. In TypeScript, we actually track nulls to the type system, so we can actually warn you when you dot into something that it may be null. So we'll give you the ability to declare things as explicitly being nullable. And then, when you do null checks, the types will get refined. So if you do something like if s is not null, then inside the body of that if statement, we will know that s cannot be null, and it's safe to call a method on it. If you don't do that guard statement with an if, we will actually say, you're doing something that's potentially dangerous here. Do you want to actually ensure that this thing is not null by introducing some check over here? Or do you want to declare at the type system level that this string can definitely not be null? Which means that the caller to that method will have to ensure that they cannot pass in a string which can be null, for example. So that's actually to be able to flow nullability through the type system and light up a whole bunch more tooling by doing so. Okay, so those are some features in C# 8.0. The second place to go, if you don't just want to see the specs, but if you actually want to see the code being implemented, is the Roslyn depot. So if you go to .NET/Roslyn, you will actually find, the C# source compiler source over the compiler source code over here, as well as Visual Basic. And so we'll actually take a look at some of that code later today in my C# language internals talk. I will actually show how some of those features are implemented by taking you behind the scenes. So those are the two places to go. With that, we're at the end of this very quick whirlwind tour through C# 7.0 and 7.1 features. You can find much more information online as well. On the MSDN site, there are sections called What's New in C# 7 and 7.1. So you can actually go over there with little code snippets to actually see all those different features in action. And with that, I thank you for your attention. If you have any questions, please come to me. I will stick around for the next 15 minutes or so. And I hope to see you sometime later this week in one of my other talks. Thank you.